Hello viewers, in the last video we were in the setup tab, and that's with our drone with a firmware fully installed and drivers fully installed. Now we'll be moving to the ports tab, and here you get everything that's capable of connecting to your drone. Well, all the ports. So generally you can see this first port, which is kind of a blurred out, you can't control it. This configuration slash MSP is communication with the drone via the USB port. So you can here see that you have USB capabilities, which is always permanent. For this specific flight controller, the Kakut H7 with Bluetooth UART2, you will not see it on the board. You will not see a label saying UART2, but UART2 is where your Bluetooth chip is connected to. So if you want Bluetooth capabilities, you're going to click on this here for configuration right here. That's generally for communication. Generally that's it. If my receiver is connected on T5 and R5, and just to make it clear, when connecting your receiver, your TX on your receiver, your TX wire on your receiver goes to the RX on your flight controller, and the RX on your receiver, this wire goes to the TX on your flight controller. So just give me a hint in case you just decide to just build it, because labels go to labels. Now, to make it a bit clearer, if I connect my receiver onto the UART7, if I have one available on my board, therefore I just need to enable serial RX right here. Now you enable serial RX when you have both a TX and a RX wire from one accessory. So my receiver have a TX and a RX because it is a crossfire ELRS receiver. Therefore I'm going to be having just serial RX right here. Now that's generally how UART works, and basically that's it. Now the other thing you have to also bear in mind is that you have different things right here. So you have sensor inputs, telemetry output, but you're going to go to the basics, because everything that you're going to install, they will give you instructions for it. Now, since I have a VTX, and the VTX trump wire, it uses the trump protocol, and that trump wire, it goes to UART3, it goes to the T3. Generally UART3, I'll be using T3 for the peripherals right here. I'll be selecting VTX IRC trump, and that's my VTX good to go. Different VTX uses different settings, and you'll always see those settings available on your manual or your documentation for your peripherals. So my VTX basically asks me to just enable the peripheral here, and if you're using there's different type of VTX. If you're going to be using a TBS, a smart audio, generally that's it here. You just click on TBS smart audio right here, and everything will be auto. So I'm using Trump protocol for this Foxy 80 channel 3-watt VTX, and that nothing here needs to be enabled. Like I said, this configuration here is useful for communications through Bluetooth, to communicate to a Betaflight configurator, to the drone, and USB also. This one here is always for when you have a TX and an RX from a peripheral going onto your board, in reference knowing that TX and RX go on the same number. So like T3, R3, that's generally UART3, serial RX have to be enabled. But in my case, my receiver goes to T3, sorry, to T6 and R6. So serial RX has to be enabled right here. So this here allows my receiver to work. So generally that's it. If you have GPS going to your board, GPS will have only a transmitter wire on the flight controller. So therefore GPS will be enabled somewhere here, but there's no GPS right here because I did not enable GPS in my firmware when I was flashing in the last videos. So right here, I don't have to put anything else. So if I'm actually using like a black box for login, all this kind of stuff, those stuff will be used right here. And I have black box enabled because I have my black box menu down here. So whenever I see the menu here, that means it is enabled, and this one shows that it's enabled by default. So I can select black box here if I want to use black box, an external black box that is. So then really that's it, and I'm going to click save and reboot. Now we'll be moving to the configurations tab, and here is quite brief and quite simple. So here you'll see your gyro refresh rate, and that's generally standard for the gyro. You can't really change it. That just tells you how fast that your gyroscope actually gets new data. So you can see here there's different refresh rates you can actually use for the PID loop frequency, and this is if you're going to be doing PID tuning. So here we have accelerometer enabled, we have baro enabled. We don't have a compass, but compass will be enabled if you're going to be using those refresh rates here. So here you have personalization. You can have an aircraft name, and if you want to name your aircraft, and also your pilot, you can have it here. Here you have camera, and you can put the camera in degrees, the orientation of it. So if your camera isn't facing directly forward, but it's facing a bit upwards, then you have a certain angle that you can enter here. But we don't usually put angle because I don't really have camera control, so I'm okay with that. So arming right here, you have safety as in maximum arm angle in degrees. So if the drone is above 25 degrees and it's not flat, then therefore the drone won't arm. So that's generally it. If you want to have a maximum arm angle, then you can put probably anything that you want. Here you can see a little question mark that'll tell you some more details about it. So basically 180 will effectively disable the check. That means your drone can be facing 180 degrees upwards or 180 degrees side, or any side or whatever it is. Now you have calibrate gyro on first arm, and that's generally if you want to calibrate the gyroscope on the first arming of the drone. And the first arming is when you plug in the battery and you arm the drone for the first time when the drone has a new battery in it, or the battery is plugged in for the first time. Now if you want to recalibrate it, you have to disconnect the battery and reconnect it, and then when you rearm, that's considered first arm. You have other features right here like air mode, so you can permanently enable air mode, so your drone is always in air mode. You have channel forwarding, and that's if you want to have servo outputs. So if you want to forward the aux channel for more than one servos, use channel forwarding, and this is only shown here when you have servos in your firmware. You have in-flight acceleration calculation, so you can have in-flight level calibration for your accelerometer. You can actually calibrate it in flight. You have LED strips, and I have LED strips enabled right there, and I'm going to disable it. But if you want LED strips, here you can see it, but I'm going to disable it. I don't need it, but instead I need servo tilt. And here you have the OSD. OSD allows you to have display on your goggles or on the screen that actually receive the transmission from your VTX. So you need OSD enabled. And I have servo tilt only because I have a servo on this drone, and that's the servo right here. If I don't have a servo, I will not have enabled the servo in the firmware. That I would not have servo tilt here because I would not have servo enabled in the firmware. So starting from the top, you have board alignment. This is my board. My flight controller is facing directly forward, how the drone is facing right here. If the flight controller was facing the arrow, instead of the arrow on the board was facing forward towards the camera, but it was facing left. Therefore, my orientation of my board will be, this is considered yaw. This is the yaw axis, so spinning around on the Z axis is considered yaw. So that yaw would be negative 90 degrees because I removed from going forward like that on my board. I oriented my board, I screw my board onto the frame facing not forward but facing 90 degrees anti-clockwise, which is 90 degrees on the negative side. So therefore my yaw degrees right here I put it as minus 90. Now, since my board is facing forward, I'm not going to do any board alignments. But if my board was like in a different kind of shape, there are these kind of drones that look like rockets. You can have your board facing directly up like this, not the frame, but your flight controller board facing directly up. Therefore, you will have this here. Your pitch would be 90 degrees upwards. If it's facing downwards, the arrow is facing downwards, you'll have it negative 90 degrees. And that's generally it. The roll is if it's on the side like this. So that is the roll axis. And how I just flip the drone there, it means negative 90 degrees because I flip the drone on the left side. So that means my board will be on the left side, but my frame will actually look flat and normal, just like how it looks right here. But my board is facing like this. If the arrow facing forward, on the left of the board facing downwards. So here you have IMU, and the IMU is enabled. And here you have sensor configuration. We don't have rangefinder, we don't have optical flow sensors, but if we did have, we will get one of those here and enable it to get the configurations for it. So we have the accelerometer trims, and we're not going to play with that. We have D-shot beacon configurations. We're not going to play with that. Basically, the D-shot beacon is like the tone that you hear when you boot up your drone and so on. Here you have serial loss, and you have serial RX. So this is a description. So you will beep if your receiver lose connection to your transmitter, and you can also have beep when it's actually set to an aux channel for a beep. And below here you have beep configurations, where generally all those here just enables you to have a beep tone for different things, like a beep for arming, a beep for disarming, all this kind of stuff. But we do not have a buzzer on this. The only noise that we can actually get is from the motors, and generally that's right here, B-shot beacon. And yeah, so that's generally it. But just a correction, the B-shot beacon is only for those two settings right here that you can enable, and that tone right now is at 1 for an instance. When you're done with every single thing that you do, click on save and reboot. It's going to save and restart your drone. Now if my drone is flat and facing forward, this is my drone facing flat and forward. Now we've gone through the setup here, we've gone through ports and configurations. In the next video we'll be going through battery, and then we're going to be going to presets. Failsafe will come after in another video, but we're not going to be doing this right now. So that's it for this video, guys. Thanks for watching, and we're almost done with this series. Stay tuned, there's much more, and see you in the next one.